going to do a new topic that is integration. Now, in order to know what is integration, then I will show you this. Okay. Now, integration is actually the reverse of differentiation or the inverse of differentiation. So if we have a function fx and you differentiate fx with respect to x, so d dx of this fx, and the derived function we call it f prime x. Okay, so actually we have two functions there, one fx before differentiation, another one f prime x after differentiation. Okay, right. Now if that is the case, then we integrate the f prime x with respect to x, you will get back the fx. So in other words, integration is the inverse of differentiation. It is the reverse process. So another time, I repeat, integrate f prime x with respect to x, you get back your fx. So all you need to do is you recognize two functions that are given to you. One is before differentiation and another one is after differentiation. The one after differentiation, if you integrate it, you will get back the one before differentiation. Okay, next. Okay, now we look at an example here. Uh, Differentiate with respect to x, 3x squared plus 5. You still remember how to differentiate this function or not? 3x squared plus 5. Okay, yes. So you bring down the index 2, multiply with 3, you get 6. Then the x less by 1, x squared less by 1 become x. So we have 6x. When you differentiate the 5, you get 0. So answer is differentiate this function, you get 6x here. Now the reverse process is when you integrate this 6x with respect to x, you will get back this one. You will get back this, okay? The 3x squared plus 5. So it is written like this. Integrate the charging sign like that. Charging sign. Okay? Integrate 6x with respect to x, you will get back 3x squared plus 5x. Okay? So we look at this picture here. Fx, you differentiate, you get f prime x. The f prime x, you integrate, you get back the fx. How to write differentiate? D dx, right? D dx of this fx. How to write integrate? You put the integration sign, then at the back you put there dx to show that you are integrating with respect to x. Okay, right. Okay, so the first example is this lah. You differentiate 3x squared plus 5, you get 6x. You integrate 6x with respect to x, you get back 3x squared plus 5. Okay. Or if you want to write in the fx form, okay, fx is 3x squared plus 5. F prime x is 6x. So you integrate this, the function at the bottom here, you get back the function at the top. So in other words, you integrate 6x with respect to x, you get back 3x squared plus 5. Okay, so far, any question? Can you understand what is integration now?
Yes, teacher.
Okay. Jia Yan, okay or not? Can understand, huh? Okay. Okay, right. So we look at another example on integration. Okay, we look at another example on integration. Right, we look at this. Now, I want to differentiate 3x squared minus 7. So 3x squared minus 7 is Same lah, 6x lah. The negative 7, when you differentiate, you get 0, right? So that's why you get 6x. So if I integrate this 6x, I will get back 3x squared minus 7. So in symbol form, integrate 6x dx equals 3x squared minus 7. Okay or not? Okay. Now, if you compare the second example with the first example, there is slightly different. Is it contradicting each other or not? Okay. Now you look at the second example, integrate 6x, you have 3x squared minus 7. Now the first example, integrate 6x, you have 3x squared plus 5. Okay. Both of them, you integrate 6x, but the answer is different. One is 3x squared plus 5. Another one is 3x squared minus 7. Now, how do you explain this? Do you know what I'm talking about or not?
Be because uh the first example they differentiate 3x squared plus 5,
Okay.
and then the second answer they differentiate 3x squared minus 7.
Okay. So by right, if I integrate 6x, let's say if I don't know the given function, the original function, I don't know. If they ask me just like that, integrate 6x dx, what do you think is the answer? 3x squared plus minus 7 or 3x squared plus 5? Which one is the answer?
Both also can.
Yes, both also can. In fact, the number at the back there, the constant at the back there, it can be any number if you are not given the initial function, the function before differentiation. So any number also can. So in other words, right, if I want to integrate 6x dx, that means 6x with respect to x, then I will get 3x squared plus a number I call c. Now this c is actually, it can be any number, right? It can be any number. So this c is called an arbitrary constant. Arbitrary constant, right? Arbitrary means it can be anything, right? Very like our ambiguous like that. It can be anything, right? So you remember when you integrate a certain function, there is always an arbitrary constant at the back, right? That is the thing. It can be minus 7, it can be plus 5 or anything. Okay?